All right, so we are going to talk about volume. Now, volume is different than area. Area is the space in a two-dimensional shape. So if I had a rectangle, the area is the space in this rectangle. But the volume, on the other hand, the volume is the space in a 3D prism or a shape, okay? Now, we're gonna do a whole bunch of different volume of different prisms, but right now we are first, in our first exercise, we are going to talk about the volume of a right prism, which is just a rectangle, or a box, if you will, okay? So now, this is the formula for the volume of a right prism or a box. Length times width, now we have to be super, super careful. This is the area of the base. Okay, so whenever we do volume, we are first finding the area of whatever the base is of the prism, and we are multiplying it by the height, okay? So the first part in this exercise 1, so we are given a rectangular right prism. It has length of 8 inches, okay? A width of 4 inches, and a height of 5 inches. Okay? Now, they first want us to find the area of the base of the box. Now, it's pretty simple with you'll see why I've stressed the fact that the area of the base times the volume is the area of the base times the height. But the box is kind of simple. So let's first find the area of the base of the box. Now we have to be super, super careful. This dark shaded part is the base of the box, okay? So I have a shape here, a prism, okay? Now it's kind of hard to see on the camera, but this up and down, this part, and this part, this bottom part, are the bases. This is the height, okay? We're gonna talk about why in a little bit, but for right now, this is the base, this is the height, okay? So this is 4, and this is 8. So let's find the area of the base of the box. So now the area of a rectangle, because the base is a rectangle, is length times width. Okay, now our length is 8 and our width is 4. So we're going to do 8 times 4 is equal to 32 inches, I don't know why I write pi, inches squared. Okay. Now to find the volume, all we're doing is taking the area of the base and multiplying it by our height. Okay, now my height is 5. So I'm going to do the area of the base, which is 32, times 5, which should give me 160 inches. So unlike area, so area we do squared units, volume we do units cubed. Okay, so be careful of the difference. All right, so the volume of this rectangular prism is 160 inches cubed. All right, now, like I said, we are going to get all different types of prisms with different kind of bases. In the first example, we were given a prism with a rectangle of a base, but in exercise 2, we have a equilateral triangle. So let's see what this example is. Okay, so a prism has a base that is an equilateral triangle. Okay, an equilateral triangle, remember, is a triangle with all the 3 of the same sides, whose sides measure 6 inches each. Okay, so this is my base right here. This is my base, and this is my base. Okay, the height of the prism is 8 inches. All right, so I have the triangle who's 6 inches each, and the height is this part. Now, we're going to talk about this especially in later examples, but I just want to make a quick point here. Whenever you're finding that, whenever the height of any prism is this long part, where if you cut the prism, like say like take this right prism right here. Okay, so we said that this was the base and that this was the base, just kind of in the way they drew the example. And this was the height. If I slice this rectangle like horizontally, the cross section would be symmetrical. Okay. Now, if we took this equilateral triangle prism here and I sliced it horizontally, anywhere I sliced it, the cross section would be symmetrical. So that's why this is the height. Okay, so we have to be super, super careful when we think about what exactly the height is of the prism, the way it's drawn. Okay, but that's a whole other point. Let's go back to the example. All right, so we have an equilateral triangle. So first off, we have to find the area of the base. Now our base is an equilateral triangle, so all sides are equal. Now we need the height for the triangle, right? My area of a triangle is equal to half base times height. Now my height, remember, is the highest point from the vertex down to the base. Now this line, the altitude, cuts the base in half because it's an equilateral triangle, so each of these are 3. Now to find the height, we need to do Pythagorean theorem because this is a right triangle and this is a right triangle, okay? So we're going to do Pythagorean theorem in using one of these triangles. So let's do 3 squared plus h squared, that's my height, that's what I'm trying to find, 6 squared, okay? So I get 9 plus h squared is equal to 36 minus 9. So I get h squared is equal to 27. Take the square root. So my height is equal to the square root of 27. I am going to leave it like this, okay, to make it easier to plug into my area of my triangle, okay? Now, the area of the triangle is a half base. Now the base, I'm going to use this whole side. So this whole side as my base is 6. Okay, my height is the square root of 27. So my area of my base is just 3 square root of 27, okay? Now, we still need to find the volume, right? So now we need to take our area and multiply it by the height. So let's do 3 square root of 27 times 8. So this is the volume, which gives me 124.7076581 is equal to 125 inches cubed. So that is my volume of the prism. All right. Now a cylinder is a solid that follows, so we're on exercise 3. So a cylinder is a solid that follows the same rules as a prism because it has a constant cross-sectional shape and area. So anywhere I cut it horizontally, it's going to be the same consistent circle cross-section. And if I slice it vertical, it's going to be a rectangle. Okay, so explain why the volume of a right circular cylinder is given by the volume is equal to pi r squared times the height. Okay, now let's look at this. We have pi r squared times the height. Now, what does pi r squared, what is that? That pi r squared is our area of a circle. Right? So remember, like I said, when you find the volume, you do the area of the base times the height. Now, since the base of a cylinder is a circle, we use that formula for the area of a circle, and we multiply it by the height. Okay, so a cylinder has a circle for the base and the area of a circle is pi r squared. So that is why the volume of a cylinder is that formula. Okay, so let's go to the next example. Okay, so I'm going to post a different video along with the video I'm recording right now explaining Cavalari's principle. Actually, it's a very important theorem, it's a very important principle, it's a very important idea. So I want to show you guys an example. This is not a proper way to show you an example. So I'm going to post a different video explaining that. So please go watch it after you're done with this. But let's go on to exercise 4. Okay. So a non-right prism has square bases. Okay, so we have square bases. So the area of a square, we're going to need that, which is length times width. Okay. 2 faces that are rectangles and 2 vertical faces that are non-rectangular parallelograms. The side view of the non-rectangular parallelograms is shown. We want to determine the volume of the prism to the nearest cubic inch. Okay. So the height. Okay, so this is one of the faces of the prism, which is a parallelogram, all right? Now, this represents the height, okay? The height of a parallelogram, like I said, is the longest point, okay? From the top of the base to the bottom of the base. Now, if we draw a line going down from the vertex, it creates a right triangle. Well, it does do that too, okay? So we have to find the height, all right, and we have to find the area of the base. Now the area of the base is a square, all right, that's why I wrote down area is equal to length times width. Now this is the length of the base right here, 4, okay, so all around is 4 of the base. So now let's just plug it in. This is my length. We'll call this my length. We'll call this my width of my base. So area is equal to 4 times 4. So 4 times 4 is 16 inches squared. All right, so that's the area of my base. Now we need to find the height. So let's go back over here. So to find the height, we're gonna have to use SOHCAHTOA. All right, so here's my person. So it looks like my x, the height, is the opposite, and the 7 is the hypotenuse. So we are using sine. So my height over 7 is equal to the sine of 58. All right, so we're going to solve for the height. So my height is 7 times the sine of 58. So all we're going to do now is we're going to take this and plug it into my formula for volume, okay? Now this part is this. So all we're gonna do is multiply 16 by 7 times sine of 58. So volume is equal to 16 times 7 times the sine of 58. Okay, so let's plug that into our calculators. So 16 times sine, 7 times the sine of 58. Oh. What the heck? Okay, there we go. All right, we need parentheses. Perfect. Okay, so volume is equal to, here, I'll show you. right there. 94.9813867, which our answer, let's see what our answer wants us to, nearest cubic inch, so nearest whole number. So this 9 rounds up that 4, so my volume is 95 cubic inches. Okay? All right, so let's go to the last example. All right, so for this one, a chicken coop. All right, so we have a chicken coop is in the shape of a prism below. Now, be very, very careful. This pentagon looking shape is our base. Right? This is the base and this is the base right here. So that means this part, that 12, is the height, right? So if I took a knife or whatever and I cut it symmetrically that way, the cross sections will be the same. So that's why the 12 is my height and not this. I know what you guys are thinking. If this is the ground and this is the top, wouldn't this be my height? But be careful. The height is where, if you cut the prism symmetrically, the cross sections will be the same. If we cut it this way, the cross sections would not be symmetrical. Okay, we need to cut it this way. So that is why this is the height and this is the base right here. Okay, so we want to determine the volume in cubic feet of the coop. Okay, so the volume is equal to the area of the base. And why I'm not writing a specific formula is because we have two different shapes here. We have a triangle. We have a triangle, isosceles triangle, and we have a rectangle. Okay, so we have two different shapes here. So the area of the base is equal to area of triangle plus area of a rectangle. All right, so okay, so let's go back to this. The volume of this prism is area of base times the height. Okay. All right, so let's go first find the area of the rectangle because that looks a little easier. So let's find that. So area of rectangle formula is length times width. So my length is one of these and my width is the other one. So 10 times 7, so 70 feet squared. Okay. Now we have to be super careful with the isosceles triangle. This is my height right here. Okay. Now because this is a rectangle, this side is 10, so each of these are 5. All right. So now to find, wait, we were given, wait a minute. Actually, we don't need to go any further because this is the height right here. We were given the height, but now this is the whole, and this is the whole base. So actually we don't need to do much. Perfect. So let's plug these things into our formula. So area of triangle is 1/2 base times height. So 1/2, my base is the whole thing, 10. My height is 4. So my area is 20 feet squared of the triangle. Okay, so the area of the base, 70 plus 20. So this the area of this triangle plus the area of this rectangle. So 90 feet squared. Okay, now, so we found the area of the base, which is 90 feet squared. So to find the height, or sorry, to find the volume, we just multiply the area of the base times the height. So multiply this by this. So volume is equal to 90 times 12. So 90 times 12 is what? feet. Remember, volume is cubed. So my volume is 1080 feet cubed. All right. So let's look at the last part. If the entire volume of air must be moved out of the coop in an hour, how many cubic feet per minute, we want our answers in minutes, must a fan move to accomplish this task? All right. So first of all, in an hour, and we want our answers in minutes. So how many minutes are there an hour? There are 60 minutes in 1 hour. Okay, so we are taking this, our volume, and dividing it by this. So 1080 feet cubed divided by 60 minutes. So the reason why we are, yeah. All right, no, so we're okay. Yeah. We're okay. All right, so my answer would be 18 feet cubed per minute. Okay, so there we go. So guys, go watch the video on Cavalari's principle. It should be very quick. Okay, it's not too bad. So, all right. If you have any questions, let me know. Okay, bye.